So I'm here with another one of Ambiq's partners, Chris from Nexperia, and yeah, they're putting Ambiq's chips to use in energy harvesting applications. So, Chris.
So Nexperia and Ambiq have been partnering on this proof of concept for energy harvesting. Nexperia is known as an essential provider of semiconductors. We produce over 100 billion parts a year. I happen to be in our group that includes power and signal, analog and logic parts, and this product here, which is energy harvesting. So we've worked with Ambiq over the last 6 months to produce this device, which is using, in this case, Bosch and TDK sensors, Panasonic PVs.
Okay.
And it is a clever system with Micro E, which is a clickable demo board system.
Nice. So in terms of Ambiq's device within this ecosystem, what makes it so great for this use case?
Well, energy harvesting in principle is about gathering ambient energy. In this case, it's pretty obviously light, these solar panels, which is fine. You can have a giant solar panel. The issue is if you want to power something like an IoT device with sensors reporting data, you want the system itself to consume as little energy as possible, which is the beauty of the Ambiq Apollo chipsets.
Cool. So let's see this in action. I see there's a whole GUI here.
It's showing the behavior of the two, and these could be anything.
Yeah.
These two parts. One is an accelerometer, and if I move it around, you can see the data changing on the positioning data. The other is temperature, humidity, pressure, air quality sensor, which if I breathed on it, it would actually report, but you can't see on the video. But this is a live demo. This is truly a functioning demo.
Cool. And in terms of working with Ambiq, what's that like? How do they make the process easy for you?
Yeah, Ambiq, obviously Nexperia is a large company. Ambiq's been a tremendous, fast-moving partner. This kind of project typically wouldn't happen this quickly, but working together with our team, the engineers, this came together very, very fast. It was, and it's obviously it's a great chip. It's a super low power. It really showcases energy harvesting. One more thing, why don't we introduce Chad Solomon from Ambiq, who we've been partnering with.
Cool.
And he can describe a couple of other aspects of the demo.
Nice. Let's hand over to Chad.
Hey there, I'm Chad Solomon. I'm also business development global. I'm helping with partner ecosystems, and Nexperia is one of our preferred technology partners. As Chris has described, we've worked quite closely together over the last few months to bring about this energy harvesting reference design. Our plan is to launch this in the next couple of months. This will become for sale through our distribution networks like Top Electronics. We're here at their booth at Embedded World, also Future and DigiKey and Mouser. One other thing I wanted to mention about the demo is that it's designed to be fully autonomous. We have early firmware now. By the time we launch, we'll have heavily optimized firmware. We've been working quite closely with Micro E. We have their click sockets on the board, and you can see this large capacitor here. That is a hybrid supercap that Nexperia recommended that we use on our module. We have an interface to use your own preferred supercap as well. If you want to bypass ours, you can do that. And one thing I wanted to mention here is that you can see on screen that we've got the supercap voltage displayed as a battery, quote-unquote, voltage, where you can watch that slowly draining as we're away from the 100-watt LED light source, and then you can watch it start to charge up as it exposes itself to the PV here. So. Yeah, really happy to be close to releasing this this reference design and working with Nexperia on future generations of your harvesting solutions.
Absolutely, more to come.
Cool. So if you want to work fast, work with Ambiq.